close this one out. Tell me when it's sent.
1949.
1949 at G.
1949?
Uh-huh. 1949.
Okay.
So let me guess, you're trying to do surface areas of cones and pyramids.
Yes.
Since that's the only really hard ones. Okay, I got your documents. Let me bring them up here. Should we start on this page?
Yeah. And then switch to. Okay, let's start on 3.
Okay. So, the way you always want to do these problems is start with the general formula. Hold on, let me get this out of the way a little bit. We're going to start on 3. It's just a good practice to start with the general formula. So, what is the surface area of a pyramid? The general formula. Now, go ahead and find it and give it to me.
S equals base plus half of the perimeter and length.
That's actually called lambda. Okay? And that's because it's a lateral measurement. In other words, that's not really the letter L, that's the Greek letter lambda. So if we want number 3, this measurement of 10 centimeters, that's lambda.
Okay.
Notice how it's measured. It's not a vertical. You don't drop a vertical from the vertex straight down. That is not lambda. Lambda is the lateral measurement. And it's a line that is, in other words, if I took that triangle and drew it, lambda is like that and makes a right angle with it. You can see the little right angle there? But it's on the outside of that triangle. It's on the face of that triangle that this lambda is measured. This question says, what's the lateral face of each pyramid? Well, which part of this general formula is the lateral face?
The base?
No, the base is that. The base is what it sets on. Okay?
Oh,
and in this case, that's a square, I presume. It doesn't really tell us, does it? No. But the base would probably be 8 times 8. But they don't ask for the base, and that's why they don't give us that measurement. So they want that measurement right there. That's the lateral surface area. Okay? So I guess we do need to know that that's a square. It's a regular pyramid, which makes it a square. So the surface area is just equal to 1/2 the perimeter times lambda. What's the perimeter?
24, or no, 32.
32. Lambda is 10. So that's 160. And that's always in square centimeters. In other words, areas, whether they're surface areas or, area of a two-dimensional thing, is always going to be in square units. Okay. Let's have a look at the next one, number 4. Same question. Surface area equals the area of the base plus 1/2 the perimeter times lambda. Again, for these first 3 questions, we only care about that part. We don't care about the area of the base. If I wanted the entire surface area, then I would have had to add the area of the base, even on that last one. In other words, what we came up with was just the area of these 4 faces. We didn't add to that the area of the base, which we would have needed to figure out the entire surface area. So in number 4, what's the lateral?
15.
What's the perimeter? Hold on, let me restate that. Lateral is not lambda. Lateral means the area that surrounds the base.
Okay.
Okay, so what I have circled over here is the lateral area. So we need the perimeter and we need lambda. And let's call that L, because that's not really surface area. That's lateral area equals 1/2. What's the perimeter here?
60.
Lambda is 15. So 30 times 15 is 450 square inches.
But where'd the base go then?
We didn't use it. Notice the instructions. Find the area of each lateral face. Okay, excuse me. Hold on. I've done this wrong. I thought they meant the lateral area of all of the faces. Well, let's go back and look at this first one. The total lateral area on the first one was 1/2 the perimeter, was 160. That was all 4 faces are 160. So the lateral area of each face is going to be divided by 4. So in problem number 3, the answer is 40. With me? In other words, we have a surface area of each face, and we have a total lateral area, which is the sum of those surface areas of each face.
So if we...
So what do we have to do to this problem to find the area of each face?
have to multiply base times height?
Well, that's actually the easiest way to do it, isn't it? In other words, I came up with the total lateral area, but I can divide that by 6 to get the area of each one, right? But there's actually an easier way to do it because I misread the problem.
Couldn't you just make a list?
I can just make the triangle, and I know what that dimension is. That's 15. And I know what the base is, 10. So the area of each face is 1/2 base times height, 75. Which you'll notice is also 1/6 of 450. In other words, the area of all 6 faces is 6 times that. But if I'm only caring about the area of that face, then I can just solve this triangle, where I know the height of the triangle is 15 and I know the base of it is 10. So 3, 4, and 5 are really quite easy, or 5 5's a little different. 5, notice that we do not have lambda. So we don't immediately know what that triangle looks like. So we kind of have to do the following. I'm creating another triangle. This measurement that they gave us, does that say 21?
Yeah.
That's that. Lambda is that. You see how I'm doing this? In other words, I'm creating another, I'm going to draw a line from there to there, creating this triangle. If I can figure out lambda, then I'll have another triangle whose base I know and whose height I know. Question is, what is that distance right there?
40.
Half of that, is it not? 40 is the whole thing. But if I connect a line from the center to the edge, that's 20. Make sure you understand how I got that.
Yeah, because it's in the middle.
Right. Now, I don't want the area of that triangle. I got to solve for lambda. What is lambda? Use your calculator and figure out what lambda is. So right triangle, you know how to solve that, right?
Yeah.
Okay, so what do you get for lambda?
29.
Exact?
Yeah.
Wow, I wasn't aware of a 20, 21, 29 triangle. That's a Pythagorean triangle that I didn't know about. Okay, now let's see if we can draw this face. You see the face I'm pointing at, the dark green face?
Yeah.
Okay, let's draw that triangle. That's what we need the area of. What's that distance right there? The vertical.
21.
No.
Well, we don't know that, right?
That's 29.
Oh, it's 29. Oh.
29. You see how I get that? In other words, this solved the triangle that I get by looking at it from the side, connecting that, and so lambda is the hypotenuse of that first triangle.
Okay.
And then once I get lambda, and I'm looking at this face, the base is 40, the height is lambda, 29. Take this face, assume it's a piece of cardboard, cut it out, lay it flat on a table. The vertical would be that measurement right there, which we've just determined to be 29. So now you just have to solve that problem. So it's 1/2 of 40 times 29. 20 times 29 would be 580 square feet. And that's the area of each face. In other words, that face is 580, this face is 580, that face is 580, and the back face is 580. They all have the same measurement for lambda.
For the first two, if I wanted to do base times height for the triangles.
Right. Now notice that lambda is the vertical for that triangle.
Yeah. Would I use, well, for, I guess, 10, would I use both of them, would I use, like,
That's the height
So 8
of
would
that
be
triangle
4
is 10.
That's 20.
Base is 8.
Okay.
So that face is 40.
Okay.
Okay? In other words, lambda is not a vertical in this pyramid. But if you were to cut this face off the pyramid and lay it flat on the table, then lambda is the vertical for that triangle. Same thing with number 4. But number 5's different. Notice that number 5, the only thing they give you is the vertical for the pyramid. So you have to create a triangle to figure out what lambda is. You see the difference between this measurement and number 5 and the measurements we had in 3 and 4?
Yeah.
Okay.
Uh-huh.
All right.
And then for this, do I have to find the base too?
Well, the base.
Or am I just finding the triangles?
Are you talking about number 5?
But that's just that one length, right?
That's what the base is. In other words, once I solve for lambda and then turn it into this bottom triangle, this base is 40. Every base is 40 on this pyramid. You kind of have to picture this in 2 different planes.
Okay.
Okay? In other words, when I solve this triangle here, the top one, I'm not looking at a triangle that's visible on our screen. That vertical that is 21 is this 21 right here. The line that I connect to this point, can you see where my hand is?
Yeah.
That's this point right here. That triangle has a base of 20 because it's half of 40. Okay, then once we solve the hypotenuse, that's 29. That is lambda. Now the face of that triangle has a vertical that is lambda, 29. And that's what I have circled and is below this. But it has a base of 40. You see why its base is 40? Look at this front base. It's got a base of 40. Same thing with the side one that we're looking at. That base is 40.
So then I would multiply 29 times 40 divided by 2.
Correct. And that gives you 580. Okay. We doing just a half hour or an hour tonight?
I think it's just a half hour.
Okay. And I'm also up for doing pieces of that. In other words, if you wanted to do 45 minutes to finish some problems or something, that's fine. I'll just bill you for 3/4 of an hour. Okay. So we can go however long you want. But if we're only doing a half hour, we only got 5 minutes left. Which problem would you like to look at? Let's do 7. It's going to be the hardest one. 6 is 7. 7. We should do 7.
Yeah.
Okay. Here's why. Because for 7, we've got to figure out. They do give us lambda. And they give us the apothem of that pentagram. Okay? So they want the surface area of the pyramid. What's the formula for surface area? Let me just say one thing about memorizing stuff, Quaid. If every time we have a session and I say, what's the general formula, and you look on the book and give it to me, or you look on your page and give it to me, that's not the best way to memorize stuff. The best way to memorize stuff is to always be testing yourself. In other words, see if you can give me the general formula from memory. Because when you take your test, they're not giving you these general formulas, correct? So you got to have them memorized. So what's the general formula for the surface area of a regular pyramid?
Base plus perimeter times lambda. Or half base
It's that
plus
right there.
perimeter.
Okay? And if you get it wrong, that's okay. In other words, if you left out the 1/2, I'll remind you, and then your memory will jog. It's just the best way to memorize stuff. The worst way in the world to memorize stuff is to always have it in front of you, always be looking at it, and then come test time, you hope that you memorized it. But that's not the way to memorize it. The flashcard routine is the best way to memorize stuff, where you're not looking at it and you're trying to draw it from your memory. Okay? What's the formula for, in other words, we can figure out the perimeter pretty easily. We can figure out lambda. They gave us that. That's lambda. That's one side. I can't read them, but you can tell me what they are. What's the area of the base?
A and S divided by 2.
1/2 ANS plus 1/2 perimeter times lambda. Well, let's just fill in everything we know. What's A?
Is the 6.9.
And it's called the apothem. And it has to make a right angle with its edge. If that distance was a radial line, that would not be the apothem. We would have to do a lot more math to figure out the apothem. But they gave us the apothem. How many sides do we have?
5.
And each side is
10.
I can't read that. Does that say 10?
Yeah, 10.
Okay. Plus 1/2, what's the perimeter? Perimeter is always n times s.
50.
Number of sides times the side length. And lambda, I can't read that either.
20.
20?
Yeah.
There's your answer. And I'll let you do the math.
Okay.
Okay? In other words, we don't need to spend time doing the arithmetic.
Yeah.
All right. The red circle, these were the ones you were supposed to do?
No, it's kind of jumps around.
Okay.
We have to do through 11.
Okay. Well, you want to stop now, or do you want to keep going?
I think that's good for right now, because we just learned this.
This number 8, don't look at that. They call that a regular pyramid, which means that right angle, that's lambda. 8 inches is lambda. But that face does not make a right angle with the base. It looks like it does, but it doesn't. It's more like these regular pyramids. All regular pyramids have the vertex directly above the middle. This vertex right here is directly above the middle of that triangle. Okay?
Okay.
Not that we need it. In other words, the only thing we need for the surface area is the area of that triangle and the area, or lambda. What kind of triangle is that base?
No, not isosceles.
No, I think it has to be an equilateral triangle. In other words, if I'm drawing the base, I won't keep you but another minute, but I can tell that this could be an unusual problem. See that base right there?
Yeah.
That has to be an equilateral triangle. So that 5, and it's that 5, and it's that 5. You have to figure out the area of that triangle, for starters. Drop a vertical, splits that into 2.5, solve for the height. Now you can figure out the area of the base. So the surface area becomes the area of the base plus 1/2. The perimeter is going to be 15, and lambda they give us is 8. So the only thing tough about number 8 is solving the triangle, the area of that base. And actually, the first part of the chapter, they do give you a formula for the area of an equilateral triangle. So you don't actually have to drop a vertical. If you know the sides and you know the formula, I think the formula is square root of 3 over 4 times the side length. Something like that. But it's in the beginning of your chapter 12. But you don't have to actually know that formula. You can solve this triangle that way and solve for the area in a typical way.
Okay.
Okay? All right. I will let you go and talk to you whenever you need help again.
Okay, thank you.
All right, Quade. Bye-bye.